In this lecture video, I will explain about the regression analysis, particularly how to fit a straight line for a given data set and how to fit a parabola for a given data set. Further, I will explain why the problems, how to solve both the problems like finding the correlation and fitting a regression line for same set of data combinedly. So let us view for regression analysis. So what is the mean by regression? So it's a mathematical measure of average relationship between two variables in terms of original units of data. So in the correlation we have seen, we can measure the how much strength is there for a relation between two variables x and y. Regression lines basically is a prediction of model. Okay, if I have positive correlation between two variables x and y, I can fit a model that best fit the data. Okay, so if variables are related, we can see via scatter plot that if points are clustered around some curve, so that curve is called curve of regression. So for example, here I am showing you a scatter xy is here. So these all dots shows points here, and these are x comma y coordinates. So we can predict some line that passes through most of the points. So this is called the best fit linear line. So we want to fit the data given via a linear line, and in otherwise we can fit by a parabola. So this trend can be seen by doing a scatter plot of given data to decide whether the scatter plot shows a pattern of regression, means linear line, or the pattern shows a kind of parabola, that is non-linear regression. Okay, so by this we can decide we have to fit or data is suitable for linear or it is suitable for the non-linear, that is parabola. So if curve is straight line, we call it linear regression, and the line best fit means your residual or the error between the actual fitted line and the data points is very minimum. Okay, so this can be done by the principle of least squares, or sometimes called method of least square. We will see later on. So in the regression, we have most common curves for fitting. So first one is here fitting a straight line y equal to a plus bx. Generally, you remember that y equal to mx plus c is a straight line. So here we are taking is a and b as. So here b will be the slope of the line and a is the y-intercept. Okay. And the second fitting is the polynomial, or you can say quadratic polynomial. So y equal to a plus b plus cx square. So here the main task is to find ABC in case of parabola, and here in case of straight line we have to find out a and b for the fitting of the line. So let's see what is the least square method. So what is our task in the regression analysis? We have to fit a model. Let's talk about the linear line. So model is y equal to a plus bx. Okay. And the data will not exactly fit this. So we write here and curve like yi equal to a plus bxi, and this is your predicted line that is with the passing through data, and there should be surely one type of error, so that we call ei, and this ei is called error or residual. So what is our task is? Our task is to minimize the square of residual. Ei square need to be minimum, and And for minimizing this, we use the method of least square. So best fit line we are finding. Now I am focusing only on the straight line. So we have to choose A and B such that this sum of squares of residual, that is I am writing here S equal to sum of EI square where I equal to 1 to n, where n is the total number of data points, that is x and y, how many values are given. So this I can write as summation. So you can see from here, if I want to calculate this will be yi minus a minus bxi whole square. And this is, so here this s should be minimized. S should be minimum. So this method is called method of least square. And now what I have to do? I have to minimize S, I have to take this concept of maxima and minima. So I have to differentiate this S with respect to unknowns, that is A and B, because there are two unknowns. So we have to do differentiate partially and equate to 0 and then solve for A and B. So in the process, I have to write here now to minimize S, what we have to do? We have to take partial derivative of S with respect to A and equate to 0, and partial derivative of S with respect to B and equate to 0. So when I do with this, remember this right side also. Here summation done from I equal to 1 to n. N is the total number of data points. So if I do that, what I will get here? By this, I will get simply, I can write here now again y and I minus a minus b xi. The square will go out to right side and becomes 0 here. And this means if I open this summation, so this means summation of y equal to n times a plus b summation of x. And if I go on the right side for this second one, and if I do that, then I have summation xi and into yi minus a minus b xi and equal to 0. So if I open this, I will get here summation of x y equal to a times summation x and plus b times summation x square. So on this, I got two equation. First one is this and second one is this. So by solving this, we will get the A and B. So this is the process of fitting a straight line. So I am summarizing here. We have what to do in the fitting of a straight line. Assumed line is y equal to a plus bx, and given are given set of data xi, yi, and these are n numbers of data points. So this means we have to write now normal equations. So normal equations we have already obtained, and its simple way to write is, so first line can be obtained by simply taking the summation of this both sides. So first line is summation of y equal to n times a plus b summation x. Here n comes because I'm taking sum over all the n data points. Okay. And next line I can obtain by multiplying this equation number 1 by x and then take summation. So this will be changed now. Summation of xy equal to this a times summation x plus b times summation x square. So here is equation number this. I can write 2 and 3, and this is 3. So our task is now to solve these 2 and 3. Okay. So solve for a and b. Once I get a and b, put into 1. By putting into 1, I will get best fit straight line for the given data sets. So these a and b I have to compute. So if I go to how to find this two equations for the given data sets, I have to compute how many columns you can see here. So x is given, y is given. I'm writing here in small place. So I have to compute now summation x. That means summation of this column. First column, summation of x is okay. Summation of y from this. So summation of x, summation of y. And then I need to compute x square. And then I have to take summation of this column and rest xy. Okay, so these two additional columns I have to compute for writing these two equations for given data sets. So let's see one example here. So here I have a given set of data points. By using the method of least square, find a straight line that best fits to the following data. And data x is given 1, 2, 3, 4, 5, and y is given as 14, 27, 40, 55 and 68. So I can easily see that when x is increasing, y values are also increasing. So it's very obvious that they have a positive correlation. Okay. So while fitting line y equal to a plus bx. So this b is the slope of the line. So this should be positive because it has positive correlation. Okay. So this is obviously now the variables are correlated, and now we are fitting this line so that we can predict. So we can predict y at any value xi. Okay. Let us suppose I want value of y at y is equal to, let's say, 7. Then I can find this value by these lines once I have obtained the state line that best fitted this data. Okay. So let's see the calculation here. So procedure of best fitting a line already I stated earlier. Now this is the assumed line and these are the normal equations. So I have to compute summation of y, summation of here x and summation of xy. So x is given, y is given, x square is computed, xy is computed, summation is taken here. So now these values should be put into these 1, 2 equations to get actual equations, and I need to solve both equations. So it's very close system. You have two equations and two unknowns. You can solve it manually like everyone is doing in +2 standard. Otherwise, nowadays you can use CalC calculator. In that, solving the system mode is there. So you can put the coefficients and you will get the unknowns. So here is the normal equations. So first normal equation is summation y equal to n times a plus b summation x. So here 5 data points are given. So n is 5 here. Remember, n is given data points, number of data points. So these are given as 5 and this 15 is the summation of x and 204 is value of summation y. xy is given as 748 and then summation x again 15 and then summation of x square is 55. So by solving these two equations, I recommend everybody to use calci to solve this system and check whether you are getting the same value or not. If it is not, practice it or get understand it how to solve 2 cross 2 system or 3 cross 3 system using calci. Okay, so after solving this, I got A equal to 0 and B equal to 13.6. So we can expect that this y-intercept is 0 and this is a kind of line y equal to A times or B times x. So here B the slope and its value is 13.6, and you can show here easily that slope is positive. Now let's come to fitting of a parabola, that is nonlinear regression. So the same process as for the straight line, and here the parabola is y equal to a plus bx plus cx square. So here a comma b comma c I need to find out, and it's very easy process to write the normal equations for parabola as in case of line I stated. So it's just a small trick here. I need to take sum of this to get equation number 1. So if I take summation, both sides, summation of y equal to n times summation this a and plus b times summation x is this x plus c times summation x square. So this b ideally should be here. Okay, and summation on x square. Then second equation I can obtain by multiplying by x both side and then take summation. So I can write here xy equal to a times x plus b times x square plus c times x cube. Once I multiply by x here and then I take summation, I get second equation. Now third equation, normal equation I can obtain by multiplying x square. So I have x square y equal to a times x square plus b times x cube plus c times x power 4. Now I'm taking summation, I get the third equation. So it's a simple process and n is the number of data points given. So solving equation 1, 2, 3, I will get A, B and C, and then I can substitute these A, B, C values here in equation number 1. So I will get best fitted parabola. So let us see a problem here. So here is the problem saying that using the method of least square approximation, fit a quadratic polynomial that best fits to the following data. So your quadratic parabola means y equal to a plus bx plus c times x square. And now based on this pattern, the values of x, y, we cannot predict anything, right? So here is the solution for the second fitting the parabola here. So we assume that this is the parabola and then I will write the equation I already written earlier. Now in this one, I recommend everyone to use the equations and then see which calculation I required. So I just said x is given, y is given. Now these extra columns will be calculated as per the normal equations. So if I see here, the first term summation y, I can obtain by summation here. Then n is the number of data points and b times summation x. Summation x I can obtain from here. Now c times summation x square, that means I need to compute a column of x square. And then I can take summation of this. And so this first equation is completed. Now second one, summation xy. So I have to compute summation xy column and then I have to take summation. And then a times summation x, which is already computed, summation x square already computed. Now x cube is here. So I need to compute x cube. So this second equation also completed. Now in third equation, left side is x square y. So I need to compute this extra column x square y. And then right side a times x square, so it is computed, x cube it is computed. Now summation x power 4. So x power 4 also have to compute x power 4. Okay, so these 1 2 3 4 5. So 5 extra columns we have to compute for given data sets, and these are computed, summation is taken here. So you can verify by your own these calculations. Maybe some mistake will be there, but just to verify. So after getting this summation of the columns required here, I can write the equations. So here the equation number 4 and 5 and 6 are there. So by solving these 4, 5, 6, I got A equal to this, B equal to 1 and C equal to 4.4286. And then I can write here this best fit parabola. Now, graphical representation you can see here. So at x equal to 0, if I see here, x equal to 0, I have a value here. X equal to 0, so this term 0, this term 0, and this minus 1.05 and minus 1.05, which is the value here mentioned because these labels are given as 0 to 10. And further, it's very important after this putting these values here, once I got the parabola, I can easily check whether given values are fitting or not. So these values may not fit exactly, but the value will be nearby because exact fitting is not there. We are fitting so that all the data points should cluster around that curve, and that you can see on this curve here. So this is almost fitting exactly, but this is not. Similarly, this is not, and this is almost fitting exactly. Okay. Now here is one more interesting problem, an advanced level problem here. So how to predict using regression model that which kind of regression line I have to fit. So for that, you can see here, uh, we have to first identify what are the dependent and independent variable, means x and y I have to find out or choose. Then by once I have given the data set, I need to check out whether the xy values follow certain pattern, whether this is for the non-linear type of pattern or linear type of pattern. So that can be done via scatter plot. This is the use of scatter plots. Where suppose I have 15 data points, I can draw a normal plot in Python, and then I can check out which kind of pattern the data sets are following. So and then I can choose the whether linear relationship I have to predict or I have to go for parabola model. Okay, so this is prediction using regression models. And then I can compute the regression coefficients like A and B in case of linear fit and A, B and C in case of the parabola. So this can be done via Excel or some software in Python or simple coding. And then I can plot the regression line and find out the slope and interceptor. So here is the one problem given here, and it's showing that the hours studied by student and their exam scores is there. So it is not given here which one is x, which one is y. So it's a general scenario that the number of hours spent by student in study will score better in the exam. Okay, so this here x I can assume as an independent variable and y is dependent variable because the marks are depending on the numbers of hours expended in a study. Okay, so the first point is okay. Second point is by scatter plot I can see here, this is the drawn in Python, so you can predict a straight line kind of behavior for the data points. So I need to find some line that best fit this data, so similar like this kind of line. Okay, so I can easily see by scatter plot it has positive correlation, and by looking at this table I can also see it has a positive correlation because when number of hours studied are increasing, exam score seems increasing. And then here I can compute the best fit regression line in previous approach. And here is something new that should keep it also in mind. So I have to fitting a equal to y equal to a plus bx. And for that, I need to compute the normal equations and then I solve the normal equations to get a and b. So from those two equations, either you can solve, or here a simplified version that b you can directly obtain by using this, and this is obtained by solving those two equations for b by eliminating a. Okay, so normal equations, if I write here, summation of y equal to n times a plus b times summation x, and if I write summation of xy equal to a times summation x plus b times summation x square. So here, if I eliminate a from equation 1 and 2, and then I simplify for b, then I will get this expression. So this you can memorize as this to directly compute b, and the column required for this are x, y, and x square and xy. Okay, so either you follow the normal equations and write and then solve by using calculator, or if you don't want to use calculator for the calculation of equations, you can directly write b equal to this and then you can use calc for the simplification of this. So that's another approach. So b here I obtain by these using calculations that you can do yourself and verify. So B I obtained as 6.23, which is slope of the line. And next I have here how to find then A if I obtain B. So A is the y-intercept. So it's one of the properties there that regression line. So regression lines passes through mean values. That is x bar and y bar, mean of x and mean of y. And that means this should satisfy y equal to y bar equal to a plus bx bar. And from here I can write a equal to y bar minus bx bar. And this means I can write here a equal to the summation of y upon n minus b summation of x upon n. Okay, so this combinedly I can write as summation of y minus b times summation of x divided by n. So here is b, not the m. Okay, so it's very simple to compute mean of x value and mean of y values, and you can use this to get a. So a is obtained here as 28.31, that is y-intercept. So your best fit regression line given as y equal to 6.23x plus 28.31, and this can be drawn here. So you can verify your values are lying closer to the given data points for particular values. Now suppose I want to compute this, and this value is given here up to up to 8. So if I want the predicted slope at or the value of y at x equal to 10, I can find out y equal to 6.23 into 10 and plus 28.31. So this is the prediction of y values from the obtained line. And this means for every extra hour studied, exam score increased by 6.23 marks. So this is all the concept I explained here. Now let us summarize it, and then I will give some practice problem for you to solve them. So first is fitting a Linear is done by least square method. Least square method. What is this least square method? This error should be minimized. That is summation s equal to yi minus a minus bxi square. This should be minimized. And the next point is normal equations for line. For straight line. And straight line is y equal to a plus bx. So I'm repeating again. The first line can be obtained by taking summation on both sides. So summation of y equal to n times summation a plus b times summation x. Because a and b are constant, so summation will run on x and y only. Second equation I can obtain by taking multiplying with x and then take summation. So xy and then summation equal to this a times x, so a and then summation x plus b times summation x square. So solve for a and b and get the best fit line here. Next point is for the parabola. For parabola, I can write the normal equations. So we have parabola as y equal to a plus bx plus c x square. And the normal equations I have here the summation of y equal to n times a plus b summation x square, not square here, summation x only, plus b times summation x square. Similarly, you can multiply by x both side and then get second equation, and multiplying by x square get third equation. So task will be to solve for a, b and c. And next what I explain is you can directly obtain b here for the straight line to obtain the b value directly by using the formula. Okay, and a you can obtain because the regression line passes through mean value. So this y bar equal to a plus bx bar. X bar is mean of x, y bar is mean of y. So by this you can directly get a value. And for b value, I shown the formula previously. By solving these two equations, I can directly write b value. So those computation required. So this is particularly important when you computed already the regression. So regression, this correlation, which I covered in previous video. So if you have not seen our previous video, you can see that one. So whenever I computed correlation coefficient, I already computed summation y, summation x square, summation xy, these quantities. So finding the best fit line, do not compute it separately. Use the table for correlation coefficient computation and then compute A by this and B by the formula I mentioned. So I hope you understand the concept of regression and connection with the correlation coefficient in this lecture video. Here I am mentioning two practice problem for you. So this problem I solved for first part in our video, last video on the coefficient of correlation. And then you can see the video and you can see what is the correlation coefficient. And then using that, you can best fit a line for the given data. So these are the problems of previous years in the exams. And here is the practice problem second. So the match numbers and score is given for the players. So determine the coefficient of correlation in the batsman runs and the number of matches played. And then use given data to determine straight line that best fit the batsman performance. That means you have to fit a line y equal to a plus bx. After that, it can be asked that estimate the score of batsman for match number 12th. Okay, so match number, if the batsman plays 12th match, what is expected match score? Okay, so this can be obtained by fitting this line, and then you can predict the value. So this is all in this video. I hope you understand.